Okay, so to begin with IP version 6, I have some document created of IP version 6. So what is the difference between IP version 4 and IP version 6? Why we need IP version 6? Anyone?
The IP shortage.
Sorry?
To fulfill the IP shortage so we don't have to use NAT. There's billions and billions, trillions of IPs.
Yes. So we were short of IP address. We will be in some years, we will be short of IP version 4 addresses. That is the reason we now need IP version 6. Okay. So what we did to consume all the IP addresses in IP version 4 till now, what we did, we used something known as our IP natting process, the subnets and all these things. Now IP version 4 is 32-bit address. 32-bit address. I told you IPv4 is a 32-bit address. We are having 4 octet. Each octet is of 4 bits. So it is of 32-bit. Okay. So 32-bit is very small address space. Okay, as compared to IP version 6. IP version 6 is 128-bit address, or you can say 16 bytes, 128-bit address. Okay, an IP address, what is an IP address? IP address is a logical address given to each and every device in the network. Okay, what it does, it identifies specific device in the network. 128-bit IP version 6 address, and there is no internal security available in IP version 4. No security, but with IP version 6 we have Ipv6 security available inbuilt. Okay, IP version 6 is a next generation of addressing using TCP/IP protocol. Now, as I told you that we need to do natting to use the IP address in very efficient ways. To use each and every IP address in very efficient way, we need to have something known as natting. Correct? We need to have natting. But here there is no need of NAT. Till now, here there is no need of NAT. Why? Because it is a very huge address space. Understood? Why IPv6 was introduced? It was introduced to overcome the shortage of address in IPv4. Okay. Now, this is the format of IP version 4. This is how we write IP version 4. Okay. And each of these separated dots are known as octets. Octets. In IP version 6 is written in this format. And each of the supported colon is known as quartets. What they are known as quartets. IP version 6 quartets. Okay. The first 64 bits in the sense, if I say you, this is how much? 4 bit. One number is of 4 bits. See, if I want to write 2, this is of 4 bit. 4 bit. 2 is of 4 bit. 0, 0, 1, 0. I can write it in 4 bit. So each digit, each number is of 4 bit. So in a quartet, we have 16 bits. In a quartet, we have 16 bits. So first 64 bits. First 64 bits are of global prefix, you can say. And the other 64 bits are of interface ID. Interface ID. Understood? Each portion is of 16 bit. We have 8 portions, that is equal to 128. Each digit is of 4 bit. Okay. Now here it is written in this way. IP version 6. So this is the format of IP version 6. Now this is a long address. We can shorten this address. How we can shorten this address? Wherever there is some rule to shorten the address, wherever there is a preceding 0 in the quartet, like this quartet is having a preceding 0. It is starting with 0. So what you can do, you can eliminate this 0. You cannot, you can just remove this 0. You can write it in this way. You cannot change this thing. You cannot change this quartet. You have to write it in this way only. And for all the 0 quartet, if the quartet is full of 0, then you can write just 1 0. Instead of writing 4 zeros, I have written only 1 0. And here also there are 4 quartets of 0. I wrote only 1 0. Now this I cannot change anything. 1 2 3 4. Here also 4 zeros in the quartet. I written 1 0 1 0. This thing I cannot change. So this is a shorten address, shorten IP version 6 address. Understood? Or I can, what I can do, if I am having continuous 0 quartets, I can remove them and I can just write double colon. See what I've done over here. These are the 2 continuous 0 quartets. I have removed them and I've just written 2 colon. Now how the device will come to know? The device will count how many live quartets are there. 1, 2, 3, 4, 5, and 6. 6 live quartets are there and total are 8. So it will assume that it will come to know that the remaining 2 quartets are of 0. Okay, either you can write it in this way or you can write it in this way. I have removed these zeros. But you cannot remove both the 0 quartets if they are not continuous. If they are not continuous, like you cannot write it in this way. You remove both the zeros over here also and just give double colons. You cannot write it in this way. Why? Because if you write it in this way, the device will assume that it will count first 1, 2, 3, 4. There are 4 live quartets. Now we have 2 blank spaces. One blank space is here and one blank space is here. Now it will assume that here is 1 quartet and here is 3 0 quartet, which is not correct. Or it can assume anything. So it will be a wrong, it will be an incorrect form of shortening the address. Understood? So the green, the whichever are in green, they are 48 bits global prefix. 16 bits are for subnet and 64 bits are for host. Understood? Now see, this is one more address. Now what I did, for all the 0 quartets till here, I just wrote this. And for the last quartet, from the left hand side, I have removed these 3 and I have just written 1. So this is the shortened address of this address, this IP version 6 address. Understood? Then we have address types in IP version 6. We have Unicast, we have multicast, and we have anycast. Okay, so Unicast is something like your public IP address. Public IP address. It is like Unicast. In Unicast also we have 3 types: global Unicast, unique local, and link local. Okay, so global Unicast is your public IP address. It is like your public IP address. Okay, it starts with either 2000. It will always start with either 2000. Okay, the first 3 bits will be always same. Okay, it is assigned by INA. The first 3 bits. If I tell you the first 3 bits means the first, this is, I'm talking about the first quartet. So the first 3 bit means the first 3 bit will be always this 001. It is assigned by INA. Okay, so either it will be starting with this 2 or 3. This is 3. It can be starting with 3 in this way. But the first 3 bits will be always same. It is fixed. First 3 bits. Okay. First 3 bits will be always same. Global unicast, it is like your public IP address. Unique local, it is like your private IP address. It is like your private IP address, okay, which is routable and which will always start with FC, FC or FD. The first 2 numbers. The first 2 numbers will be always FC and FD. The rest of the numbers can be changed. Means the first 7 bit are same. The first 7 bit will be always same. This green one. Okay. It is not recognized on the internet. Okay. With the same organization, LAN or WAN. Understood? So this is something my unique local. My link local is default IPv6 address on every IPv6 enabled interface. It is non-routable. If I enable IP version 6 on any of the interface, I will get this link local address. Okay, understood?
Yes.
Link local address, the first 10 bits will be always same. Routers do not forward packets with link local addresses. And remember this thing. Multicast addresses, like the multicast addresses we were having in IP version 4 for different protocols, like IP version, so OSPF was having multicast address 224.0.0.5 and 6. EIGRP was also having multicast address. RIP was also having multicast address. In this way, we are having multicast address over here also. Okay, so it will be starting with FF00::/8. Understood? FF00::/8. Got it? Now you people know how to assign IP addresses on how you can assign IP addresses on IP version 6 address. Do you people know? Robert, no,
Yes.
I taught him. Robert knows. Others, Pawan and IKIS, do you know how to assign IP version 6 address on a device?
Yeah, I know the command, but I haven't tried it.
You haven't tried it.
Yeah,
You want me to show?
yeah, please.
Okay. Okay, it is there over here. Let me check if IP addresses are configured or not. Show IPv6 interface 3. There is no IP address. Good. Show IP protocol. There is no protocol. So just consider we are having two routers only over here, R1 and R2. R1 and R2. Okay. R1 and R2 are the two routers that are there over here. This is my IP addressing scheme. In the LAN of R1, I'll be using FC00 colon 11 colon 11 colon 11 colon 1. Okay. And in the WAN, I'll be using 2001 colon 12 colon 12 colon 12 network, one over here and two over here. See, IP addressing scheme, IP addressing, the rule to assign IP address is also same. The scheme is also same. All the things are same. Just we need to, the commands are somewhat different. The LAN of R2 will be FC00 colon 22 colon 22 colon 22 colon 2. Okay. So we'll assign IP addresses. Now, how to assign IP addresses?
I have a question here. One question here.
Yeah.
The fourth octet, the fourth quartet is the subnet, right? So on serial 30, both sides, the fourth quartet should be same, right? If it is not same, then they will not be able to communicate.
Where? On which address you are, on the LAN or on the WAN?
On the WAN side, both interface, both the router interface on the WAN side should have same subnet, right? The fourth quartet.
Yes.
If it is not, then this will not be able to communicate, right?
No, they will be not be able to communicate.
So 1, 2, 3, 4. Fourth is the 12. Let's say if at the fourth there is double colon, okay, then how we will know what is there? It is 0 on the fourth quartet. Or
see, if you have written where it is, here you are saying that there is 0 on this 12 place of 12. There is.
Let's say if the if it is double colon, then we will consider it as a 0 or what?
Yes, we will consider it as a 0 only.
The subnet can be 0.
Yes.
If it is 0 means what? It is a like /32 or like.
See, here it is only /64.
No, what it is equivalent something in IPv4. I'm just trying to correlate. Because in IPv4 there is no 0 subnet, right? 000 subnet is not there.
000 subnet is not there in IP version 4. Here you can have the 0 subnet. How?
Okay.
You will have a 0 network because you are not having any class IP address over here.
Okay.
You are not having classes. You are not distributing the classes. You are having a bunch of IP address, and all the IP addresses you are using. You are using all the IP addresses. That's what you did. You divided them from the first quartet. This is my global unicast. This is my unique local.
Private IP means unilocal. Yes, unicast.
Yes. This is my private and this is my public.
Global, yeah.
Get it?
Okay.
Now I need to assign IP address. Okay, so same thing you have to do. Go on the interface fast Ethernet 0/0 for LAN. The thing you is change over here is IP version 6. Over here you have to write address, then the address FC00 colon 11 colon 11 colon 11. See, this 11 means I'm having zeros over here. In the preceding, I'm having zeros. This is what 11 means. I've removed the preceding zeros. I'm writing a short address colon 1. Okay. Then the subnet mask value 64. No shut. No keep alive. See, in IP version 6, if you are not connecting a physical link. See, I have not connected a physical link on the fast Ethernet interface. So you have to always give a command. It is a best practice to give this command, no keep alive. Okay, no keep alive command. You can use it over here. Then interface serial 3/0 IP version 6 address. What is the address? 2001:12:12:12:1/64. Okay, no shut. Here you don't need to give no keep alive because you have connected with the physical link. Same ways on the R2 side also, IPv6 address FC00:22:22:22:2/64. Okay, no shut, no keep alive.
No keep alive is for what?
See, when you are not connecting any physical link, you are
On
not
the
connecting.
LAN side.
Yes.
On the WAN side, we are already connected, right?
On the WAN side, we are only already connected. That is the reason I'm not giving no keep alive.
Okay.
Okay. Interface serial 3/0 in the WAN. Address 2001:12:12:12:2/64. No shut. Exit.
Sorry, I
Now
have
to
one more.
verify the IP version 6 address, you have to give show IP version 6 address. Okay, show IP version 6 interface brief. Okay. See, I got the IP version 6 address over here. So IP version 6 address. This is my link local address. It automatically came. This is my link local address. This is your EUI64 format. What it is? It is your EUI64 format. EUI64 format. You will get a link local address which will be starting with FE80 if you enable any interface with IP version 6. See, I enable both the interfaces. I configure these IP addresses, but I got these this link local address over here. This is my EUI64 format. This is my EUI64 format. Understood? If I'll try to ping 2001:12:12:12:2, I am able to reach. Understood? Show interface fast Ethernet 0/0. If I give over here, this is my what? Hardware address, my MAC address, correct? This is the MAC address of the device. Now link local address, you can say may be assigned manually by an administrator or by operating system procedures. Okay, most often they are assigned using stateless address configuration, auto configuration. This part is known as stateless auto configuration. Stateless auto configuration. Okay, so how it is been assigned, how the link local address is been assigned? Do you know how the EUI64 format? Do you people know EUI64 format?
Yes.
Okay.
No,
Others?
please explain.
Others?
No, I don't know. Please explain.
Okay. Just I will explain you what is EUI64 format. Okay. How the link local address is been formed.
I have one more question here.
Yep.
can you go back to the GNS3, the diagram? So here on the serial 30, you have used /64. We can use also /127, right? Because /127 we will be having 2 IP, right? And in /27 here in IPv6 we are not having like broadcast IP or network IP, right? We don't have those things.
See, here we don't do subnetting. Till now, no one has done subnetting with IP version 6 address.
Okay.
Okay, whatever you are telling me, it is of subnetting part.
Okay.
After subnetting only we do the things, right?
Okay, got it.
We'll get to IP address in a subnet. After subnetting only we do all that things.
Understood.
So here there is no need of subnetting until now because you are having a huge address space. See, we have not started yet using the IP version 6 address. Okay, so there is nothing like we can do. So we have to do subnetting now. Okay, when it will be started, then the concept will be more cleared. So for now, whoever is using IP version 6, they use /64 as a subnet mask. Understood? I was explaining you EUI format, EUI64 format. Okay, see here it is EUI extended unique identifier format. Okay, so I'll take the example of the MAC address that we got on our side over here. This is the MAC address. This is the MAC address that we got. Okay, now how the link local address has been formed? IP address is of how many bits? It is IP version 6 is of 128 bit. This is a 48 bit address. This is 48 bits. Okay, this is 48 bits. Now what we have to do? So I told you the first 64 bits. The first 64 bits will be FE80 FE80 colon. This will be the first 64 bits. Okay, first 64 bits. Then the next 64 bits will be your MAC address CC01. You can say colon 1330 colon 000. Now this is 48 bit. Okay, now how we can make it 64? So extended, you can say EUI 64 format is something that we have to add in the middle of the MAC address. We have to add something FF colon FE. FFFE. What we have to add? We have to add FFFE. Now this became my 128 bit. This became my 128 bit. Got it? Now always the MAC, always when we are dealing with the MAC address, the 7th bit, there is a rule. When you are forming a link local address, there is a rule that always the 7th bit will always get changed. 7th bit will be reversed. 7th bit will be reversed. Now what is my 7th bit? Here first two, these form 8 bit. 7th bit, if I want to write CC, how I will write CC? What is C? A is 10, 11 is B, C is 12. If I want to write 12, how I will write? 1100. 1100. This is CC. What is my 7th bit? 4, 5, 6, 7. If the 7th bit is 0, make it 1. If the 7th bit is 1, make it 0. It will be always reversed. Okay. Now what is the output of this? This is how much? 14. This is 14. 8 plus 4, 12 plus 2, 14. And 14 is what? 14 is E. 14 is E. Now my address becomes like this. The EUI format address becomes CE. This will be my link local address. If you want to see, you can see over here. See the link local address. FE80. This is the first 64 bit and this is the last 64 bits. We have added FFFE. We have added FFFE. Understood?
Just repeat once again how did you do the subtraction?
Okay. So suppose I'll take another MAC address over here. Suppose this is the MAC address I took. This is the MAC address I took. Okay. Now this is 48-bit MAC address. Okay. Now, as I told you, always my link local address will start with FE80::. First 64-bit will be always this number. First 64-bit will be always this number. Then comes the second part, second 64 bits. So what I'll do, I'll paste this over here. The MAC address, whatever the MAC address we got, will paste over here. Now, how the link local address is formed out of this. So what they do, they add FFFE. FFFE in the middle. In the middle of the MAC address, they add FFFE. Now this became 64-bit, 4 quartets, 64 bits, correct? 64-bit, 48-bit MAC plus FFFE become my 64-bit. Now the rule says 7th bit will be reversed. 7th bit from here, if I say from here 7th bit, this is, as I told you, every number is of 4 bit. So this is 4 bit, this is 4 bit. 7 bit means if I want to write over here AB, these are my first 8 bits. Okay. A means 10. How I will write 10? 1010. This is 10. How I want to write B? B means 11. 11. This is my 11. Now here you can see 6 and this is my 7th bit. So if it is 1, you have to change it to 0. If it is 0, you have to change it to 1. Now what is the output of this? A and 8 plus 1, 9. A9. My MAC address will become now, my link local address will now become this. Sorry. A9. This will be the link local address. This is known as EUI64 format. Understood, Pawan?
Yes, it's clear. Thank you.
Okay. Now we can change the link local address also. Link local address may be assigned, you can say manually by an administrator or by operating systems, procedures, whatever the things we need to do, or using stateless auto configuration. Okay, so we'll see the default link local address is FE80. Okay, So I will change the default address to something else. Okay, so how I can do? See, this is the link local address. You can see show IP version, show IP interface brief FE80. FE80. Okay, so I want to change this address. I want to change this address. How I can change? See, one thing I can do it manually. I can go on the interface and I can say fast ethernet 0/0 and I can say IP version 6 address FE80::1. This is the address I want on router 1. Okay, I want it on R1 FE80::1. This should be the link local address. So I will say link local over here. IP version 6 address FE80::1 link local. It got changed. FE80::1. It got changed. Okay. If I want to change on R2 also the same command interface fast ethernet 0/0.
What if we change? We put something else other than FE80? Will it take or it will
No,
not take?
it will not take. Link local address is always starting with what you say. Link local address will always start with FE80 only. If it
What
will
error comes? Just try. Okay.
IPv6 address FF80::2 link local. Saw the error?
Invalid.
Invalid link local address. It will always start with, see, it is given by INA. This is fixed. First 64 bits are fixed. It will be always this address only, FE80. The next 64 bit can change. Understood? Okay. Now as we have routing, we in IP version 4 we have routing over here also. We have routing over here also. We have routing protocols like static, RIP-NG, OSPF version 3. We have MPVGP, EIGRP version 6. Okay, so IP version 6 uses the same types of routing protocols as IP version 4. So with, you can say, with some slight modification to account for specific requirements of IP version 6. So IP version 6 routing has to be enabled. You have to give this command. IP version 6 unicast routing. See, some of the iOS, if you go on some of the iOS devices, iOS things, some of the routers and some of the devices are having the IPv6 unicast routing enabled by default. Okay, on some of the iOS devices, you have to enable it. You have to enable it. Okay, you have to give this command IP version 6 route unicast routing. Okay, now as we were having the static route, we are having the static route over here also. The syntax is same. Like if I try to ping from R1 to R2's LAN, I'll not be able to ping because there is no routing. There is no routing. So what I need to do, I need to configure routing. How I can configure routing? There are different routing protocols. So first one is static routing, IP version 6. The command will be always starting with this IP version 6 route, destination network address, destination mask, next hop address. Understood? IP version 6, like we used to give in IP version 4 also, here the syntax is same. IP version 6 route, and what you will do? You will give the things over there. Okay. So let us see static routing first. How to configure static routing between these two routers. So I'll make it short so that you can see the things correctly. IP version 6 route. What is the destination network? FC00:22:22:22:22. Either I can give 0 over here. If I don't write 0, then also it is fine. I can just give the subnet mask, because if I don't give 0, it will automatically take that the : is of 0 quartet only. Okay, so I'm configuring static routing so that R1 and R2's LAN, they can communicate with each other. Okay, what is my next hop address? 12:12:12:2 is my next hop address. Correct? On R2, IP version 6, FC00:11:11:11:11/64. My next hop is colon 12:12:12:1. Okay. Or I can give exit interface also, S3/0. S3/0 exit interface. See, I have options over here. Sorry, I did give route over here. I have options over here. I can use the exit interface. I can use the IP version 6 next hop address. I can use anything. So if I give the, let us take the address only, next hop address only. Okay. Now, if I need to verify the routing, the same command just with IPv6 over here. Show IPv6 route to see the routing table. S, I am getting S over here. C means connected, L means local. You can see over here. Okay. FC, I have the network address over here. Okay. Now, if I try to ping, I am able to ping. If I try to ping from the source, I'll say use the source as the FC00:11:11:11:1. I am able to ping from LAN to LAN. I am able to ping from LAN interface to LAN interface. Correct? Now, as we have static routing, we have default routing also. So what we'll do, we'll remove whatever we have configured over here. I'll remove the static routing. Okay, if I try to ping, I'm not able to reach. So I'll configure now R1 and R2 so that they can communicate each other using default routing. Okay, so default routing is also same as we used to do in our IP version 4. The concept is same. Okay. IP version 6 route. Now, either I can write it in this way: 0:0:0:0:0 5 6 7 8 0. it is wasting my time. What I can do, I can just write 0 colon, double colon and 0 with any network and any subnet mask. Any network and any subnet mask. If anyone is coming from any network and any subnet mask, send it to the next hop address. Okay. Or I can write it in this way also. IP version 6 route. Instead of writing 0, I can write double colon 0. That's it. It will come to know that double colon means all the quartets are zeros. The next hop address will be 2001 colon 12 colon 12 colon 12 colon 1. Here what I've given 2. Yes. See, I got a static default route over here. S. If I try to ping from source to source, I am able to reach. If I try to ping in another way also, without the source, I am able to ping. Understood? This is how you can configure static and default routing. Got it? Any doubt till here?
No doubt.
Sorry?
No.
Okay. Now we have, as I told you, we have different routing protocols over here. But in our syllabus, we are only having OSPF version 3. If you want, I can show you RIP-NG and I will show you OSPF version 3. Okay. How to configure OSPF version 3. Because we are only having OSPF version 3. Okay.
That's kind of difficult to hear you.
Sorry?
It was difficult to hear you there for a second. I can hear you fine now.
Okay. So OSPF version 3. Now OSPF version 3 based on OSPF version 2, we have OSPF version 3 something enhancement. There is something enhancement that is done in OSPF version 3. So the enhancement is it distributes IP version 6 prefixes, runs directly over the interface. How it runs directly over the interface, I'll show you. Now here adds IPv6 specific attributes. In the OSPF, we will add the specific attributes like 128-bit address. We get the link local address. We can have multiple address and instances per interface. Authentication. OSPF version 3 runs over a link rather than a subnet. OSPF version 2 in IPv4, we used to have it on a router mode. Here we will be running it on the interface rather than on the subnet. Understood? OSPF version 3. Now the concept are all same. What we have on in the IS in the concept of the things are all the same. Like we need whatever we configure in OSPF version 3, all the things are same. How it works, all the working is also same. Now what is my plan over here? My plan is, as it was there before when we started, it was already there. This will be in a specific area. You can say this will be in area 10. And this complete will be in area. So I'll not just consider, because I will not see the router. The complete this thing and this LAN also will be in area.
You can take
0.
it in background. You just click right. It will be like the button.
Sorry, what I can do?
Click right click. Yeah. Lower one layer. Just lower one layer. Yeah.
Okay, thank you. So this is something, my area 0. Now how to configure our OSPF? How to configure OSPF? So let us go on the router, remove the default route. Okay. Now I'm in the global configuration mode. Now I will enable OSPF. To enable OSPF, I have to say IP version 6, router OSPF 1. See, once I enable, I'll get a prompt. Just read that prompt. What it is? IP version 6 routing not enabled. So what I have to do? IP version 6 unicast routing. First I have to enable the routing. Then if I give, I'll get one more prompt over here. See what it is. What it is showing. Read it out. Robert.
OSPF process 1 could not pick a router ID. Please configure manually.
Yes. Now in OSPF version 3, it will not take an IP version 6 address as the router ID. Router ID will be always an IPv4 address only. Understood? So in whenever you are configuring OSPF with IP version 6, you have to manually set the router ID. So I'm setting it 11.1.1.1.1.
Which
Any
that's
random
best
IP address
practice.
you can take. Sorry?
That's best practice as well, right? Always set in the router ID.
Manually in IP version 4 also, it is a best
Yep.
practice.
Got it.
But
But
just
in
one
IP,
thing.
yeah, sorry.
Just one thing. Router ID in OSPF is not IPv4, right? It's like 4 octet. We can also put 0.0.0.1 as a router ID, right?
Okay.
Yeah,
Robert,
I
we had
think
a discussion, I think so at the CCNA level about this router ID. Robert?
I'm sorry, what?
We had a discussion about this router ID. You are also confused, I think so, in this router ID. So always remember the OSPF router ID is used to provide a unique identity to the OSPF router. Okay. It is an IP version 4 address, 32-bit binary number. It will be an IP version 4 address. Understood? it will be always an IP version 4 address, an IP address. Okay.
Okay.
Now this is what I have enabled OSPF and I've given the router ID. Now, if I want to run this in a specific area, what I'll do, I'll go in the interface, fast Ethernet 0/0. Or what I'll do first, best practice is to create area 0. Okay, so I'll go in interface serial 3/0, and here I have to give a command IP version 6 OSPF, then the process ID. Process ID is 1. Then I have to give the area and the area ID. So this will be in this interface will be in area 0. What I'm saying, this interface serial 3/0 will be in area 0. Okay. This is how you configure OSPF version 3. See, interface fast Ethernet 0/0, IP version 6, OSPF 1. My LAN of R1 will be in area 10. Understood? Let me go on R2. IPv6 router OSPF 1, IPv6 Unicast routing. See, again I will get a prompt that router ID is not selected. So router ID 22.2.2.2 suppose. Exit interface serial 3/0, IP version 6, OSPF 1, area 0. Exit. See, the neighborship came up. Interface fast Ethernet 0/0. Same command IP version 6 OSPF area 0. Okay. How I can check? To check the command is same, just we have to add show IP version 6 OSPF neighbors. Who is my neighbor? 22.2.2.2. Okay. I can see show IP OSPF, show IP route OSPF, also show IP version 6 route OSPF. I am getting a route over here. Okay, I am getting a route over here. This is how I can configure the OSPF FC00 colon 22 colon 22 colon 22 colon 2. I am able to reach. I can reach. Okay. So this is how you can configure OSPF version 3. Got it? Any doubt? Any doubt?
No doubt.
Okay. Okay, here I cannot show you the EIGRP. We are not having EIGRP in our syllabus. We were having some time, so I was just trying to show you. I can show you EIGRP as well. Let me take these two routers over here. They will be having the option of EIGRP. See, we have the option of RIP, but we don't have the option of EIGRP. So till the time the routers get started, we can configure, you can say we can configure RIP. Okay, so no, no. Show IPv6 protocols. There is no protocol statically connected. Okay, no protocol is running. Now if I want to run ripng, that is my IP version 6, what I need to do to configure ripng, the command is same, IP version 6 router rip, but here we have to give a name. Suppose CCNP I gave, router rip CCNP. Okay, exit. As it does not need router ID, I have exited. Okay, now the name used for process ID should be the same in order to exchange the routes. This is the process ID name. This is the process ID name. Okay, so I'll say interface fast Ethernet 0/0 IP version 6 RIP CCNP enable. IP version 6 RIP CCNP enable on LAN exit interface serial 3/0, the same command. The RIP is enabled now. On the other side of the router, IPv6 router RIP CCNP. This should be same. Okay, the process ID name should be same. Interface fast Ethernet 0/0 IP version 6 RIP CCNP enable. Sorry. Okay. Interface serial 3/0. Now if I want to see show IPv6 protocol, see I am running RIP CCNP on both the interfaces. Interface serial 3/0 and 0/0. Okay, I am running it on both the interfaces. I can see the routing table also. Sorry, not OSPF, it is RIP. Okay, RIP routes I am getting over here. If I try to ping, I am able to ping. Okay, understood? This is RIP and EIGRP version 6. Now EIGRP, I will be seeing over here, show IPv6 interface brief. No IP address. First, I'll configure IP address. Gigabit 0/1 IP address, sorry, IPv6 address. FC00:11:11:11:1/64. No shut, no keep alive. Interface serial 3/0. Sorry, gigabit 0/0. 2001:12:12:12:1/64. Interface gigabit 0/1 IPv6 address FC00:22:22:22:2/64. No shut, no keep alive. Interface gigabit 0/0 V6 address 2001:12:12:12:2/64. No shut. Okay. IP version 6 router EIGRP and the autonomous system 100. Unicast routing. Okay. Now here I have to give no shut command. Router ID 11.1.1.1 exit. Interface serial 3/0. Interface gigabit 0/0, that is my connected to R2. IPv6 EIGRP 100. This is only the command. Interface gigabit 0/1. Then here also exit IPv6 unicast routing, IPv6 EIGRP, IPv6 router EIGRP 100, router ID 22.2.2.2, no shut.
Why we are giving no shut command here? Inside
This is something used. No shut command is mandatory. Okay. See,
okay.
In whenever we are using EIGRP, we have to enable the EIGRP and we have to give the no shut command. It is something mandatory command. No shut is the mandatory command. The router ID is optional, but no shut command is mandatory over here. Interface gigabit 0/0 IP version 6 EIGRP 100. Their interface gigabit 0/1 100. Okay. Now I can verify show IP version 6 EIGRP neighbors. See my neighbor Okay, is my neighbor with the link local address. If I see show IPv6 route EIGRP, do show history. I should get a route over here. IP version 6 EIGRP 100. /0 and 0/1. Show run. I am not getting the routes. No valid route for destination. I don't know what is the issue. Okay, let it be. Might be there is some issue of this iOS version or something. I don't know. Any doubt in IP version 6?
No.
This is what we have in our syllabus in IP version 6. Okay. Any questions?
Nope.
Okay, so I will give you a task for IP version 6, like whatever we had. This was our topology. This was our topology that we were using in all the labs. Now I want you people to configure IP version 6 IP address over here in this topology. Okay, like you can create loopbacks, like you will say loopbacks will be 2001 colon 1/128. Okay, 2 loopbacks over here. And between these two, R1 and R2, you will be using something like 2001 colon 12 colon, you can use anything. X, I'm giving network. Okay, you can use, this will be in between R1 and R2. Between R2 and R3, you will be using 2001 colon 23 colon X/64. 2 and 3. Between 3 and 4, you will be using 34. Here you will be using 14 or 41, whatever you like. So I'll be using 14 colon X/64. This is the IP addressing scheme. And here also you can create some loopbacks like 2001 colon 222 colon 1/128. 2001 colon 2222 colon, here it will be double colon, okay, 2/128. Same way here it will be 3 2001 colon 333 colon 1/128. 2001 colon 333 colon 2/128. Here it will be 4 2001 colon 444 colon 1/128. 2001 colon 444 colon 1/128. Configure this and try to configure
That should be 2.
OSPF, RIP-NG and all the routing protocols. You're asking
That should
anything?
be yeah, that should be colon 2/128,
Yeah,
right?
sorry. Here it will be
That's fine.
colon 2. Understood? These are the loopbacks. Got it? Any doubt?
It's like dual stack, right? We have to keep IPv4 also, right?
Yeah, you can keep IPv4 also. If you have previous IPv4 things configured previously, you can keep IPv4 also.
Okay.
Or just give IPv6 IP address, anything you can do, whatever you like. But I need IPv6 address.
Okay.
Okay. Any questions?
No questions.
Okay. So we'll meet tomorrow.
Your topic